So as you can tell, there are some similarities in these properties. And as it turns out, it's because they are a certain type of material, either an acid or a base. HCl is a very well-known acid, as you know, hydrochloric acid. Um, and notice that turns blue litmus red. Um, let's just look at other things that turn blue litmus red. Oh, Sprite does that. Guess what? It's an acid. Lemon juice does that. Oh, guess what? It's an acid. And so we have these acids. Acids turn blue litmus red. That's one characteristic of acids. The other thing is, in the presence of bromethymol blue, notice that they're going to be yellow colored. Okay? Then we have red cabbage. By the way, bromethymol blue changes color around a pH of 8 or 9. Red cabbage, as we saw yesterday, has a range of changing colors. But the more acidic it is, the redder it is. And so therefore, HCl is dark red. We had lemon juice that was red. And Sprite was kind of a purplish color, but all on the acidic side of the spectrum. And then reaction with magnesium, notice all the acids reacted. The reason why we proved this yesterday is because you do the burning split test and it releases hydrogen gas, which is important. And then you have reaction with sodium bicarbonate. Sodium bicarbonate is a base. It's baking soda or baking soda. It is a base. And so it will react with an acid. However, it will not react with a base. And so when we say no, that's because we are not getting any kind of reaction with a base. So now NaOH is a very well-known base. It's like the standard base. Notice it does not change blue litmus's color. It keeps it blue. It changes bromethymol blue to blue and green. There's a transition between yellow and blue, so it's like not quite as basic as sodium hydroxide or like bleach, but it's on its way there. Then we have red cabbage that is like a bluer color. And we did have a little bit of green there, which was a little bit curious, but and then reaction with magnesium and reaction with baking soda, bases don't react with those things. And so these are bases. Should probably just call those singular bases, not plural bases. So that's how we need to think of this. Now the question is, why are they acids and why are they bases? So let me explain why that is. So there's this thing called Arrhenius acids and bases. And Arrhenius acids are pretty simple. They are acids that ionize to form, like an Arrhenius acid is an acid that will ionize to form the hydrogen ion. In other words, this is what the reaction looks like. It's very simple. HCl will break down to form the hydrogen ion plus the chloride ion. That is pretty simple. So the reason it's acidic is because it has a hydrogen. So Arrhenius acids have hydrogen and they dissociate to form hydrogen ions. Simple. And the reason we know that they form hydrogen ions is because they do all conduct electricity. That's pretty basic. Oh, no, acidic. I'm sorry. So what about Arrhenius bases? Well, NaOH would dissociate to form the sodium ion plus the hydroxide ion. So, do you want to know why it's an Arrhenius base? Well, it's an Arrhenius base because it has an OH in it, hydroxide ion, and it dissociates to form hydroxide ions. That's all the Arrhenius acid and base is. If there are Arrhenius acids and if there are Arrhenius bases, they will have the characteristics that we described up above. It's pretty simple. And so you're going to do some examples of writing these dissociation reactions for Arrhenius acids and Arrhenius bases.